Hi, I'm John Greenwald, National Sales Manager for TESCO, the Eastern Specialty Company. Today I'm here to talk to you about our new 1029 Vacuum Assist. This is a great product for those meters where you want to pick up a pulse from the meter, but you don't have a good landing spot for your optical pickup. You can simply line this guy up, find our spot where we're getting pulses, and turn it on. You can see now this seamlessly sticks to the meter with no hands. It's a great product for those of you who are tired of fighting with suction cups that just are ineffective or just don't stick to the meter. The unit comes with a USB battery pack, and it even sticks when I turn the generator off. Another problem solved by TESCO, the Eastern Specialty Company.
So anyways, I guess we'll get started here. My name is Dan Holler. I'm the Rocky Mountain Regional Manager. And today we're here to talk about optical pickups and optical probes. Actually, as this morning and yesterday evening, I started thinking about this, and I really didn't include a lot of history of the use of optical communications as it relates to metering. I have been in this industry since 1988, and optical communications have been around since then. Basically, there is an ANSI spec C1218. That's for a standard protocol for two-way communications. And optical ports have been around since I started in this industry in the late 80s. Early days when I started in this industry, there were no solid-state multifunction electronic meters as we know today. Back at that particular time, there were something called box recorders. They were just a NEMA type enclosure with a board in it, and they counted KYZ pulses that came from electromechanical meters with pulse initiators in them, and then they'd feed those KYZ contact closures into a board, and those pulses would be counted. KYZ is just a single pole double throw relay, and back in those days they were mercury wedge relays inside the electromechanical meters, and in those days they would fire a light beam with an LED and a photo transistor at the spinning disc, and some discs would have holes in them. Others would have a black stripe of paint on them. So when that beam would hit the black stripe, it would not bounce back, creating a pulse on the photo transistor. Or if it had the hole in the disc, the light would penetrate and go through the disc during that revolution of the mechanical discs and create a pulse in the same way, except going through a hole instead of not bouncing back from that black stripe. So I really didn't discuss that, but in those days of box recorders and hybrid registers, these were the precursors to the modern day electronic meters most of us are using today. The hybrid registers were basically an electromechanical meter that had been retrofitted with a solid state register. And there were a lot of players, you know, there was GE in that market and Process Systems and DAC and quite a few other players. So optical communications have been in the metering industry since before the electronic meters that we all know today. The first meter I ever saw that was solid state was a Scientific Columbus Gem 1 meter. And then in the 90s, basically all of the other major meter manufacturers started coming out with solid state meters. And they would all pretty much at that point have optical ports on them. And some would have standard old-fashioned POTS line modems. Those are just dial-up modems, like some of us may remember from the old days with AOL and dial-up modems. This was pre-internet. And anyways, let's just jump into the presentation here. I'm sorry I neglected to include any historical facts here. So optical pickups are a one-way device. They're just basically the meter putting out an infrared light pulse from the meter relative to the energy usage. And that is picked up by a phototransistor in the optical probe or the optical pickup, as it may be. So a pickup is just a one-way device. It's just counting infrared pulses that it sees that are being output by the meter. So as the meter outputs a pulse, each one of these pulses have a weighted value associated with them relative to the energy that the meter is seeing at any point in time. And that value of the pulse has a K sub E value associated with it that is used by a shop test board or a field test kit to determine the accuracy of the meter. So these pulses get counted. They have a known associated weight with them, and then it determines the energy consumption for a test like a full load test or a light load test or a full load power factor test. And while the meter is undergoing these test sequences, the meter is putting out these infrared pulses, and those pulses are being counted by the piece of test equipment, whether that be shop or field test equipment. There are some meters out there still in the industry that do not have metal plates on the front of the meter. So those meters typically have a raised plastic ridge. Sometimes they're triangular, sometimes they're semicircular. And in those cases, there are adapters like these 1041s down here that will allow you to put these adapters on those types of meters that don't have the metal plate, because optical probes have a magnet in the head that sticks to the metal plate on the front of the meter. If the metal plate doesn't exist, you can use these type of adapters to put them on those meters to give them the metal plate. So this is what they look on the back side off to the left, and on the front they would look like on the right. And there's your metal plate for the magnet in the pickup or in the optical probe to adhere to stick to the front of that optical port if they don't have that. Let's go ahead and go to the next slide. So on the left, we have an optical pickup on a meter in the field. So this meter over on the left is being tested in the field with a site analyzer. And that type of device is testing the meter for accuracy under customer load. It can also be tested under phantom load. So if this is a dead service, such as an irrigation type service, a pivot, or some sort of irrigation pump, those are deactivated typically 6 months out of the year. So in those kinds of cases, you may have to have battery powered test equipment, since a lot of times they even disconnect the line side voltage. So the meter itself may be dead or the meter may be energized, but not seeing any current outputs from the CTs. In those cases, you have to use a phantom load. So when you're out in the field testing, you're either using the actual customer load, and this pickup is on there and it's counting these pulses, or you're using a phantom load for a service that may not be active at the time, like an irrigation type load or a seasonal type load of some sort, a recreational vehicle park or something that tends to be a seasonal thing. Over on the right is a shop test board, and it has an optical pickup on the top. The optical pickups can be put in whatever position they need to be able to count those infrared pulses and calculate the energy the meter is seeing and reference that back to an internal reference standard in the test device, whether that be a field test device on the left or a shop test device. The infrared LED that's putting out the infrared test pulses can be in various locations. Some come right out of the optical port itself on the front of the meter. Some come out on the top, like you see this one here on the left, excuse me, on the right. That one has it at the 12 o'clock position. This particular configuration is somewhat problematic, so we've created a product that allows it to hold it in place where that infrared LED is on this particular meter and be able to pick up that pulse uninterrupted. And some of the meters will have them coming out at the 9 o'clock position, some at the 3 o'clock position on the face of the meter. So the infrared test pulse can come out of various locations depending on the meter manufacturer and the vintage of the meter. Sometimes they'll even move the location of the infrared LED on a given manufacturers as they come out with their next generation product. But a good portion of them use the actual infrared LED in the optical port itself. So we're going to run a little video here that shows one of these in operation.
In this segment of the presentation, we're going to cover optical pickups. Here we have a TESCO 2990 meter test board, and it's got a Form 2S Class 200 Clara i210 Plus meter in it. So what we're going to do, instead of running an accuracy test, I'm just going to apply the maximum current that this board can output, which is 50 amps. Apply that to the meter, which will cause rapid pulsing on the pickup. And there's an LED on the pickup that will indicate every time a pulse is output by the meter. So we're going to go ahead and put the pickup on the meter. In this case, the infrared test pulse is output through the optical port on this particular meter. On some meters, it's located in other places other than the optical port itself. It can be at the 12 o'clock position, the 9 o'clock position, the 3 o'clock position, dependent on the meter manufacturer type and where they've located their IR test pulse. So we're going to go ahead and turn on the current to this meter, as I said, at 50 amps. And you'll notice the rapid pulsing of the LED on the left. That red LED indicates every time this pickup is seeing an infrared pulse from the meter relative to the meter's load that it's seeing. So this is 1/4 of full scale for a class 200 meter. So you're getting very rapid pulses on there. This is a one-way pulse. It's just coming out from the meter and being counted by the software in the test board.
All right. So let's move on. These are what some typical reports would look like. The one on the left is a report from a test board, from that test board we just saw. So it will have all the information on the meter, the case of H value, the form factor, when it was tested, who tested it, what it was tested on. And it would also have all the results from a full load, a light load, a full load power factor test, and then ultimately at the bottom, a weighted average, which takes into account all three of those tests and gives them the weighted average. Over on the right is a screen from a test that was performed in the field with a piece of field test equipment, in this case, R6330. And that's the kind of thing you'd see using customer load to run a test on a meter. And that pickup you saw on the previous slide on the left would be on the front of the meter. It would be counting those pulses. But in that case, it's not a load created by a device through like phantom loading, like on a field test kit where you don't have service live at the time you want to run the test. You'd have to induce a phantom load, phantom current to the meter so you could run a test. This test over here on the right is with actual customer load. So it's being tested with whatever the load is on that customer at that moment in time, and then giving you a pass-fail indication based on, you know, the results of that test and how many pulses it saw. So let's move on to the next slide. So an optical probe, that's a two-way device. These devices have been around since the late 80s. They might have been around a little earlier than that. Sometimes the term was used in the old days of Opticom. That was kind of an industry standard term for them in a generic sense back in the late 80s. And those Opticom registers, again, Opticom probes were using that C1218 standard. It's full two-way communications using an infrared LED and a phototransistor. And there are basically two flavors of optical probes in modern day metering. And the original one obviously was a hardwired optical probe, and there were various manufacturers throughout the years that made optical probes, some of which are still in business, others have gone by the wayside. A lot of the meter manufacturers also made their own optical probes. Ideally, the term came out in the early 90s, I believe, is when I first heard it, of a universal optical probe. Universal optical probe simply means that the optical probe was universally compatible with all types of meter manufacturers. So it would work on a GE Aclara meter, it would work on an Itron meter, it would work on a Landis and Gear meter, it would work on an Ion meter, it would work on, you know, whatever meter, Honeywell, Elster. So those were universal optical probes. whereas some probes in the early days would only work with a particular meter manufacturer's device. So once the universal optical probes came out, it made it easy for the utility to use meters from multiple vendors and be able to communicate with them with the vendor software and that universal optical probe. The typical communication speed, and this has been this way for quite some time, is 9600 baud. That's the typical communication speed through an optical port. However, there are some meters that can communicate at higher speeds through the optical port. Not a lot of them that I've encountered. So that is the typical speed. Some of the older meters, obviously, and those box recorders and hybrid registers that would retrofit under the mechanical meters, those communicated at 2400 baud, and even in the early days, some of them maybe at 1200 baud. But that's the typical speed now, is 9600 baud, but some can do 19.2 or even faster. So typically when you're communicating optically with a meter, the meter manufacturer software is used. So if you're reading a Honeywell meter, you're using MeterCat. If you're reading a Clara meter, you're using MeterMate. If you're reading Landis & Gyr, it's 1132Com, Itron, it's PC Pro Plus. So typically you're using that vendor software to either read or program a meter or reprogram a meter. There's also third-party software out there. I'm familiar with a package called MVLT, and that was multi-vendor laptop. So it was a piece of software that started out way back in the early 90s that had the protocols for all the meter manufacturers' meters. So you'd take that universal probe, you'd hook it up to a laptop, and you could go out and probe, a GE Aclara meter, a Landis & Gyr meter, Itron meter, Honeywell meter, all with that same probe, all with this one piece of software. So that was very convenient for utilities that did not want to have to run 3-4 different pieces of meter manufacturer software to extract the data and save it as an HHF file on that local laptop. And then that HHF file would then go and be imported into another system, such as MV90 or other head-end systems that could import that HHF file, which is an industry standard format now and has been for quite a few years for devices read in the field optically rather than remotely through various communication mechanisms, whether that's hardwired phone lines or if they were reading them via IP connections, direct IP, cellular communications. So there are lots of other ways to get the data in. But whenever you read a meter in the field optically, you would store that locally on that laptop that is doing the reading. Sometimes handhelds would come with optical probes as well. And then they would store that data they read from the meter in that HHF file. And that HHF file was the mechanism to move that data from the handheld or the laptop into that head-end software, and then ultimately to billing, load research, load forecasting, other systems that utilize that data from the meter. And when we talk about data from the meter, what we're typically extracting when you read a meter optically with the meter manufacturer software is basically everything that meter is capable of storing. That would be all the stored registers, whether they're cumulative registers, instantaneous registers, demand, voltages, currents, all the types of registers that are programmed into that meter can be extracted through the optical port, as well as interval data, load profile data. Those words are synonymous. And also things like history buffer, sometimes called an event log as well. And also things like alarm conditions. So a lot of meters are set up to generate alarms if they see a voltage sag or a voltage swell or total harmonic distortion threshold exceeded. So all of the data that's in that meter can be extracted through the optical port using the meter manufacturer's software, whereas typically some or a good number of the AMI systems on the market today just retrieve a subset of the data that's stored in the meter rather than absolutely everything that's in the meter. And when you read it with the meter manufacturer's software optically, you're going to get absolutely all the data that's stored in that meter. Let's go ahead and run that video there, the probe.
For this segment of today's presentation, we're going to demonstrate an optical probe. Optical probes are used for two-way communications between typically the vendor software and the meter through the optical port on the meter. Optical ports typically have that metal plate for the magnet in the optical probe head to adhere to. So we're going to go ahead and put that on there. If they do not have the metal plate for the magnet on the optical probe head to stick to, then we make adapters that will go on there and give it that metal plate to stick to. Then the cable is just an off-the-shelf USB to mini USB cable. Standard length that we ship them with is 6 feet, but any length can be purchased at any number of places. And if the cable ever gets kinked or broken, you can always go out and buy a new cable and replace the cable. Whereas some optical probes, the cable is a part of the probe itself, and if that cable gets damaged, that's the end of the probe. So we're going to go ahead and initiate a communication session. When you communicate optically with a meter, it is not physically connected between the meter and the laptop or desktop being used. It is an infrared light, basically, communicating with the meter using an infrared LED and an infrared transistor. So it's serial communications with no physical electrical connection between the meter and the laptop or desktop reading. So I'm going to put this thing into the online view, which is a continuous communication with the meter. And you'll notice that the LEDs on the optical probe head are flashing back and forth, indicating that there's data transferring back and forth between, in this case, the 1132 COM software and the meter. I am not aware of any other probe on the market that has transmit and receive LEDs like this TESCO 1038. But this will allow you to go out in the field and read meters, reprogram meters, extract data that you can't get because maybe your AMR module or your AMI module has quit. So you can use the optical probe and the optical port to read the meter and get that data out, or reprogram a meter, let's say for net metering. And when you initially put it out there, the customer didn't have solar panels on their roof, and now they've installed some. So you have to go out and reprogram that meter to do net metering. So that's just a scenario where you might want to go out and program a meter in the field. Typically, they come pre-programmed from the manufacturer, but there are instances where you may want to reprogram the meter. Typically, that's done with an optical probe through the port on the meter. And that's about it for optical probes.
All right. Well, that was your typical optical probe in action there. In that case, I was just doing a continuous read of the meter. I could have been doing an all read or short read or just reading a subset of data, but I just put it into a continuous loop so you could see those LEDs blinking. Having those LEDs on the head of the optical probe is very helpful in troubleshooting. So if you're trying to communicate with a meter and you're only seeing one of those LEDs flashing, that means that commands are coming out from the meter manufacturer software or the software being used on the laptop or desktop, and it is being seen by the probe, but you're not getting any responses from the meter. The meter is not responding to the commands being sent to it, so you're not getting any received information from that meter. So having those LEDs is very helpful. I'm a big fan of LEDs when it comes to communications because it kind of lets you know what's happening during a communication session and where the nature of the problem might be as a result of not seeing one of the LEDs flashing. You can say, oh, it's not responding, or I'm not getting any pulses from the optical probe, which means maybe there's something wrong with the optical probe. Maybe you haven't configured the vendor software properly to use the correct port that optical probe is connected to. So there are a lot of good reasons to have LEDs to let you know what's going on in the interest of troubleshooting any communication problems you may have. I'm going to show you a device that is using the optical port on the meter. It is not an optical pickup or an optical probe. It is unique in the industry to my knowledge. And the device you see on the unit on the left that's on that Aclara meter is called a safety disconnect device. It uses the optical port on the meter. And this particular device sole purpose is to open or close the service disconnect switch inside of a meter. So a lot of you out there have AMI systems. You're starting to purchase meters that have service disconnect switches in those meters. Those service disconnect switches allow you to remotely open or close that switch in the meter with the AMI head-in. And this allows you to turn customers off for non-payment and turn them back on when they come in and pay their bill without having to roll a truck and go out there and pull the meter and boot it, or pull the meter and put in a meter cover. And that requires a lot of man hours and resources and possibly unpleasant interactions with that customer you're shutting their power off with. So now in the modern day AMI world, you can just connect to that meter, basically hit a few keystrokes and shut that customer's power off. They come back in and pay their bill. And then you can remotely connect to that meter and through the AMI head-end software and turn that customer's power back on. Now, there are a lot of instances, for whatever reason, let's say you're using power line carrier communications. Your neighbor may have cranked up his arc welder, which is going to put out an enormous amount of harmonics. And now the adjacent house that has a meter with a service disconnect switch, and you're using power line carrier communications, they can't communicate with that meter. That PLC communications module is not a bad module. It's just being interfered with by an enormous amount of harmonics being put out by an arc welder or similar devices that can also introduce harmonics onto the fundamental waveform. So in that case, you might have to send a service personnel out, somebody on call, a lineman, anyone. It's a very simple device to use. You put it on that port and off it goes. So Andy, let's go ahead and run the video.
Right before the video, Dan, I have a quick question coming in here.
Okay.
What is the purpose for meter manufacturers to make meter covers without the magnetic connector these days? They say they think it would be an industry best practice to make them all with those options, despite potential cost savings, making them completely plastic.
Actually, that exact question has occurred to me on many occasions. When I first started seeing meters in the industry with no metal plate on the front, I'm thinking to myself, well, they saved a nickel, they saved a dime, they saved an insignificant amount of money on a metal plate. The reasoning behind that, I would have to assume, is cost savings. But when I try to apply that rationale to it, it's like such an insignificant amount of money for a metal plate. I really can't justify the decisions that some meter manufacturers made to eliminate that metal plate and just put that plastic ridge on the front of the meter, knowing that you had no way to connect an optical pickup or an optical probe that has a magnet in the head to adhere to it. So I don't have a good answer as to why some meter manufacturers chose to go that route, or for that matter, why some meter manufacturers that have optical probes on their meter, they have the optical port on the meter, but yet their infrared test pulse LED is at 12 o'clock or 9 o'clock or 3 o'clock. So I never have been able to understand why a utility would not utilize the infrared LED in the optical port itself, or why they would not include that metal plate other than cost savings. So you got me on that one. I don't really have a good explanation of cost savings, but to me, the cost savings does not outweigh the fact that now you have to deal with something and create an adapter with a metal plate so you can connect to a meter with an optical port like that. So that's the explanation I can get. Is I just don't know what the thinking was on the part of some of those manufacturers that elected not to include the metal plate.
We actually had another comment come in here. Oh, now it just popped off my screen. On LNG meters, it is an option on the covers to get the metal plate. You can specify if you want it. And to follow up with Patrick's first question, who asked the question, he said that was the story here. It's frustrating working with these covers without the adapters. So yeah, I guess there's no rhyme or reason that we know of otherwise, but yeah, it is frustrating.
It is unusual. Speaking to the Landis & Gyr specifically, I don't understand it. I have one of them here myself. This is the type that has the triangle. I don't know how well you can see that right now because I'm not seeing myself. But this is an adapter that's got that triangle, it would pop onto the meter. On the other side, you have the metal plate. So this little adapter will allow you to deal with that. It's called a 1041. We make these types of adapters for all the meter manufacturers that don't include the metal plate on the front of the optical port.
And I actually did throw that link in for those port adapters on the chat if you guys want to check them out.
Yes, they're very helpful, and it is kind of frustrating to get out to a site and you're ready to read or reprogram a meter, and you walk up to it and you're like, well, gee, how am I going to get this thing to stay on there? I've been on the field with technicians that physically hold the optical probe on the front of the meter and then balance their laptop. So, you know, they've got their hands full doing that. It is a real hassle. If I were in a position like with Landis and Gear, I would elect to pay whatever that extra money is and get the metal plate on the front of the port. Any other questions on this one?
So one more question coming in here. Will the optical port adapters hold up the 1039 WP probe pickup, or will it weight be an issue? I don't know if you want to wait till we get into the wireless one, or do you want to answer that before I play the other video?
The simple answer to that is it will absolutely hold the weight, and video will show you that it does.
Yep. Okay. So with that, we'll go ahead and show the video. And this is the 1039 safety disconnect.
In this segment of the presentation, we're going to cover a device that uses the optical port on a meter, but it is neither an optical pickup or an optical probe. It is a unique device called a safety disconnect device. This device goes on the optical port of the meter and opens or closes the service disconnect switch inside the meter for turning a customer's power on or off for residential class meters. This is a standard class 200 form 2S residential meter. This is an Aclara i210 Plus meter. This particular meter does not have the metal plate on the optical port, so we're going to use this little gadget here that will go on the front because it's just got a raised plastic ring. Now that snaps in there plenty tight. Then we'll take the safety disconnect device, put it on the front. It has basically 3 buttons, and that's all there is to it. It contains the passwords for this particular meter, which is what allows it to send a write command, which is what a service disconnect open or close command is. It's a write level command, so it requires administrator level password, which has been programmed into this device that corresponds to the password in this meter. We go ahead and we turn on the power. It is naturally sleeping, and turning on the power wakes it up, in this case for about 10 minutes before it shuts off again. That's a programmable feature. So very simple. I'm going to put this test board in a particular mode, which is called the disconnect mode. We'll tell it what kind of meter it is. We'll turn on the voltage. You'll see the 2 LEDs on this device came on. This is for each jaw of the meter on the load side, indicating that there is load side voltage present. So now we'll go ahead and open the disconnect switch by pushing one button. Now the customer power off or switch inside the meter is in an open state. So all you have to do, since the device is still awake, is go ahead and hit close. You'll notice the 2 LEDs on the test board are off, indicating the open state of the service disconnect switch in the meter. So now we'll just hit close, and it will close the switch in the meter, turn the customer's power on. There's a little delay on this particular meter, a little different than other meters. Some meters have a delay, others do not. I can actually remove this device at this point and just wait a bit, and then the contacts close, customer power is back on. So that's another device that uses an optical port on a meter, and again, that's a 1039 safety disconnect device.
I have a question, Dan.
Sure.
Is your little mountain goat friend there supervising your meter testing?
Yes, he is. I have a whole fan club of various mountain animals that make sure that I do things correctly.
Okay, I'm gonna bring up the WP video next for you.
So as she's bringing this up, the device on the right that has a red body is a disconnect device, and it also is a wireless probe. So these two devices have one thing in common. They can both trigger the disconnect device in the meter, open or close it. But the one on the right with the red body is also a wireless probe. So I'll let you run it.
Okay.
In this segment of my presentation, I'm going to try a different type of optical probe. I personally prefer wireless optical probes. The main reason being inclement weather. If it's 106 degrees outside, I don't want to be standing outside with a laptop in my arms or on a table or any other way. I have a hardwired optical probe hooked up to the meter and stand out there in that heat for however long it takes to read or reprogram a meter. Conversely, I would not want to stand out there in 0-degree weather, holding that laptop in my arms with a 25-mile-an-hour wind or even more, especially here in the Rocky Mountain region where I live. Sometimes the weather can be very unpleasant, and I really don't want to stand out there with a laptop and read a meter. The best part about this is you can go ahead and put the device on the meter, run back to your truck, and read it from the comfort of your truck. Today I'm changing it up a little bit. We have a transformer rated 9S Itron meter here, and this is the 1039 WP. It is also a safety disconnect device in addition to being a wireless probe. It is not Bluetooth. It is a radio device and has a range of 1,200 feet and uses this little radio, USB. Looks like a USB stick, memory stick, but it's not. It's a radio. So I'm going to plug that into my laptop, which will stay back in your truck. And then this particular meter has a demand reset switch that's very close to the optical port. It will stay on there and it will communicate. I've done it many times, but it's more likely to fall off given a little bit of a push. So I'm going to use this 1041 adapter. This particular adapter was initially designed for meters that have just a circular plastic ridge that protrudes from the meter cover. In this case, I'm going to be using it as a standoff to get away from that demand reset. Now you've got a good firm connection here. So this device has to be woke up. So I'm going to hit the on button and wake it up. You'll get a little LED flashing there. Then I'm going to go to the vendor software, in this case PC Pro Plus, and I'm going to start a communication session, log on to the meter. And as you can see, the LEDs are blinking now. You see those transmit and receive LEDs flashing back and forth, toggling back and forth between transmit and receive. That tells me there's full two-way communications taking place right now. So now I've connected to the meter. So this is just the log on process I did. After it logs on and can see the meter, then I can have it do various operations. I'm going to do a toolbox because that's a reasonable amount of data that it pulls back. So now you can see those LEDs just going crazy. Right now, I'm not applying any load, but I could put the load on, it simulating more real-world scenario. So now I've got a load on the meter, I'm reading the meter, or I'm programming the meter. And it is much better from the comfort of your truck in inclement weather or just in general. And this thing will work. I have personally tested it at 300 feet. Will work up to 1,200 feet. And you can read or reprogram those meters from the comfort of your truck if you have sites where you can't get your truck within 30, maybe 50 feet, if you're talking about a Bluetooth type radio, as opposed to the radio we use. And that's it for the 1039 WP and wireless probes and why I prefer them.
So anyways, that is a really handy little device. I personally like them for the reasons I cited in the video. And I am not aware of any other wireless probe on the market that has the kind of range that that probe does. Most of them use Bluetooth technology, which gives you 30 to 50 feet, best case scenario. These are used at much greater distances. I think 1,200 feet. Most people would not want to put this on a meter and run 1,200 feet back to their truck. But if they did, they'd be able to do it. One of these days, I'm going to test it at its max extreme limit. And I got to park down the street. I'll run down to the park with my truck and leave a meter plugged in with the 1039 WP and read it from the park, because that's about 1,000 feet from my house. So that will be an interesting test, but I have every confidence that it will work. And it is very convenient. Like I say, if you're out there and you're holding a laptop in your arms and the weather is not pleasant, it is no fun. Plus, just sometimes it can take quite a while to extract, multiple channels of load profile data and all the rest of the data that's contained in a meter. Or if you're reprogramming a meter, that can take considerable time. And it's no fun, even if you have a table or a way of setting that laptop down, you're still out in the elements if the weather is very hot or very cold. So even if you're not holding the laptop in your arms with the hardwired probe hooked up to the meter, it's still so much better to just go back to your truck and read it or program it from your truck. It is just, to me, the cat's meow. So let's go ahead and move on to the next slide. So optical probes and pickups troubleshooting. This was something that was kind of a last-minute suggestion by Andy, and she was very correct in having me address this. A lot of times people can't communicate with their meter optically, and they don't know where to start. So what do? I can't talk to the meter optically. Is it the meter? Is it my optical probe? Have I incorrectly configured the vendor's software and I'm using the wrong port? So there are a lot of things that go into communicating optically with a meter that need to be taken into consideration. One of the ways to really find out what's going on, and I used to use these many, many years ago. It's been a long time, maybe 25 years or so since I've used these little things you see at the bottom. Is sunlight is also a big problem. But what these little cards at the bottom do is detect infrared light, which is not visible to the human eye. But one of the common issues I hear a lot of in the field is somebody goes out there with a field test kit with an optical pickup, or they go out there with their laptop or their handheld and an optical probe connected to it, and they want to communicate with the meter, they want to read the meter, they want to reprogram the meter, and the sunshine is directly overhead, and it's just beaming right down on that meter at the right position. And that sunlight can just totally saturate the phototransistor in the meter. And a lot of meter manufacturers have taken many lengths and done things to prevent this problem from, the ambient light from the sun getting in there, because the sun does contain infrared light. And if that infrared light saturates that phototransistor, you are not going to be able to communicate with that meter. So a lot of times I've seen people take a notebook, their hat, many other things, and put it over the meter to shade the meter so the sunlight's not coming in on that optical port. But that is a big problem. Some vendors have actually taken little plastic plexiglass rods and put them in the optical port to channel that infrared light into the infrared LED and detector on the optical port. So then you have a way of channeling that infrared light so it's less likely to be disturbed by ambient light coming from the sun. But that's one of the bigger problems I've heard about, and either shading that meter or some of the precautions meter manufacturers have taken using the plastic rod, which basically works like a fiber optic cable, channeling that infrared light, or they get the optical probe so close to the infrared LED and infrared phototransistor that the light from the sun cannot get in there and obscure the infrared photo detector, the phototransistor. So it's nice to have these little cards. So if I wanted to figure out what's going on, so I've got my laptop, I'm running my meter manufacturer software, I have my hardwired optical probe hooked up to it, let's say, and I get one of those little cards down below. There's different vendors that make these things. They're easily found on, I just Googled it, and Amazon and eBay. Everybody's got these things. I actually use the one in the center from Lumitech 20 some years ago. So they've been around a while. It's basically a piece of blotter paper soaked in a chemical that allows infrared light to be seen by the human eye. So when you hit those little squares of paper with infrared light, the infrared light becomes visible. So the first thing I would do in using one of these, and I have many, many years ago when I was a test department supervisor running a production test department for a meter manufacturer, I would hook up my probe to the laptop, run the meter manufacturer software, put that optical probe head over that card where that piece of yellow paper is. On the right, it's a white piece of paper that's treated with that chemical. Put the optical probe head over that card and then start the communication session on the vendor's software. You should see flashing. If you don't see flashing, then that means the infrared LED is not flashing and pulsing as it needs to. So that tells you the problem is on the laptop or on your optical probe, not on the meter side. So what you can do is go back and check to make sure that you have the correct COM port for the optical probe that you have hooked up to the meter. So if the optical probe shows up in Device Manager on COM4 and you have the meter manufacturer's software set up for COM6, clearly you're not going to get any pulses out of that optical probe. So that tells you, hey, I've misconfigured something in the software and I've got it on the wrong port. So then you go and select the proper port. Yes, the optical probe is on port 4. I saw that in Device Manager in Windows. And then I try another communication session and I hold that optical probe head over these little cards with the paper on them. And I see the flashing. Okay, great. Now I know that the infrared LED in my optical probe is working. I've got my software configured for the proper port. So now let's put it back on the meter and see if I can communicate with it. If you can't communicate with it, then you know that it's something on the meter end, that the meter is, maybe lost its mind and firmware has got off into la-la land. The optical port itself may have a problem with the phototransistor, the infrared LED on the meter, but at least this is a way of allowing you to determine, is it the meter, is it the optical probe, or is it the way I've configured the software to communicate with that meter? So it can be a very, very big help in troubleshooting to figure out where the problem lies.
We actually had a comment come in, Dan, from Jeff saying the camera on a cell phone will make the infrared visible also. Are you familiar with that?
I am. I have not used my phone for that purpose before, but when I was doing the videos, I noticed that when I had a load on my meter and the optical probe was not hooked up to the meter, and I was filming the meter on that 2990 with my webcam, I could see the infrared pulses coming out of the LED on the meter. I could see the pulses. But when I turned and looked at the meter, they were invisible to the naked eye, but they are not invisible to the camera eye.
Oh, that's pretty cool.
But I won't dig into that. But it was a Warehouse 13 episode where people could see things that were not visible to the human eye. So yes, phones and cameras can see the infrared light.
Well, that was a great comment. Thank you, Jeff, for that.
Yes, that was an interesting comment, and I noticed it. I'm like, wow, that's pretty neat, but I neglected to bring it up in this presentation, so thanks for that.
Well, I know what I'm going to try later in the office here.
Yes, you can point your webcam, or that's how I figured out, is the webcam, and you can see that pulsing, but the meter has to be under load to get those pulses. And then I turned to the meter and I saw nothing. So that was kind of interesting. And I knew that was the case. I just never really thought about it until I started doing those videos. All right, let's move on to the next slide. So here is your typical meter tech out in the field with a Panasonic Tough book. This is old timey. This is probably a 15-year-old picture or so. So he has his Tough book and he's out there in the field. He's holding it in his hands. He's got his probe hooked up to his Elster A3 meter there, and he's reading or reprogramming. I think he was just reading the meter in this case. This was a case where this meter could not be read by their existing AMR system. And they had to go up to the top of this mountain. This is at a gold mine in Montana. So you had to go through some rigorous training and where the helmet and the vest and watch a video for 20 minutes just to get on the property of this gold mine. So I was up there with them, and we were swapping out the meter you see there for a cellular meter, a meter with a cellular communications module. So they didn't have to go out there, go through all the trouble of going up the hill, going through a 20-minute safety video to allow them access to this that wasn't even in the gold mine. It was just on the property of the gold mine. So this was what I would call a hard to read squared. This was a hard to read meter. It was very problematic, and it was a prime candidate for AMI or a cellular based surgical deployment. And that's what we were doing here, is surgically deploying a cellular based meter that could be read through, in this case, Verizon. So anyways, that's just obviously you can tell by the scenery that that is Montana. Go ahead and move on to the next slide. So all of these are some of the devices that we make that utilize optical ports on meters. The safety disconnect device, our meter site analyzer, which is a full-blown site analyzer that tests the meter, that tests the CTs, that tests all the wiring in the site. That also has an optical pickup, as you saw in one of the earlier pictures. Then the standard hardwired optical probe you saw in one of the other videos, the 1038 with the LEDs on the head, which are very helpful. The wireless 1039 WP, and all of our test boards, obviously the 2990, 3050, our multi-position boards, all obviously have optical pickups. What I neglected to mention, and this struck me a little too late as well, is in the old days, you can move on to the next slide. In the old days, before solid state electronic meters, and even before box recorders, but box recorders kind of came along at the same time as electromechanical meters equipped with pulse initiators. But before that, the pickups actually had to do two things. They had to fire a beam at the disc on a mechanical meter, and the beam either struck a black stripe of paint on the meter and didn't reflect back, so it didn't hit the phototransistor, which created a pulse, or there would be a hole in the disc, and that beam would go through the hole in the disc and then hit the phototransistor on the other side, making a pulse. And when it hit the silver disc, it would just bounce back and not go through the hole, or it would not reflect back when it hit the black stripe on a mechanical meter. So they actually had to fire a beam, an infrared beam, at the disc of the meter, and then have that phototransistor determine whether or not that bounced back or it didn't. When it didn't bounce back, that created a pulse, and that's how they managed to retrofit those old mechanical meters, or how you test a mechanical meter on a present day board. If they are just the disc meter, you fire that beam at it, you adjust your optical pickup, and then it works with those old mechanical meters as well. I didn't touch on it because mechanical meters have basically been obsolete for about 20 years, but there are still quite a few utilities I run into out there using mechanical meters, and they know what I'm talking about when it comes to lining up that beam and firing it on the rotating disc in the mechanical meters and having to line it up properly to get those pulses. So we'll go ahead and open up, see if there's any more questions.
Yeah, we have the chat open for you guys. If anyone wants to unmute and ask a question, if that's easier, certainly can do that. And while you guys are typing in any questions there, just to show you what's coming up for the next few weeks, we have a two-parter for traditional ratio burden admittance and DMAG testing, and that's with Rob Reese, our Midwest Regional Manager. And then we have Paul Fratellone, who is our TESCO software, realizing your investment in technology through analytics, and then we'll follow up some shop testing, preparing for AMI deployment, and communication equipment, rounding out this series for TESCO Tuesday. Did I hear someone unmute? You have a question?
Hey Andy, it's John. Presentation, Dan, really cool. I just happened to have with me, I think you showed them already, but for those, I think it was Brad who asked the question before about some of the meters. I've got what actually have a, I think what is it? It's a Focus AXR SD Form 2S. And you'll see on that one, that's not a magnetic connection on there at all. So this is the original star we made, which will fit on it. it will go, but then it falls off. So we made this one, which is the other one that comes in the pack, which is shaped, and that's not going anywhere. So that right away is a really quick method to put that on, and then we can just use one of our standard connections here. Stays on. I was hoping that didn't fall off, and it didn't.
That was a great demo.
There you go. Demo in 30 seconds. That's what we do at TESCO.
That was great. Thank you, John. And yeah, we did have a question for that. So that was great to show them. So thank you for that. And I don't see any questions coming in. It's just about noon here. So you guys have been really patient. Thank you guys every week coming back. We like to always give you guys some good content, some different content. We've been experiencing the live videos and having some technical difficulties. It does happen, you know, so we're trying to get better each week. If you guys have something that you want to see that we're not doing, you know, shoot us an email. Let us know what you're looking for. We'll try to do that as well. So I don't know, John or Dan, if you can answer this. The adapters, are they available individually? How do you guys package those?
Yes, they are. So go ahead, Dan. Go ahead, Dan.
Yeah, they can be sold individually. You know, you might want to have one for each meter tech so they can have them in their truck in case they encounter one of those meters that doesn't have the metal plate. So yeah, we have many different varieties for different meter manufacturers that don't include the metal plate on the optical port. And we sell them individually, or you can buy multiple. And like I say, if you've got, you know, 5 meter techs or 3 meter techs, and they all have a laptop with optical probes, and they're going to be going out and reprogramming or reading meters optically, you want to make sure they all have one. You also want to make sure that when they leave the site, they don't leave the adapter on the meter, because then they'll get to the next meter and go, oops, I left my adapter on that last meter, and have to run back to that meter and get their adapter back. So that's why we make them red, so they stand out. When you walk away, if you see red, you forgot to remove the adapter.
Yeah.
All right, guys. Well, thank you for that. I don't know. Do you guys have anything else to add? I don't know if we're getting many more questions. It might be top of the hour. People got to go. It's almost lunchtime here on the East Coast. Maybe everybody's shy. So, all right, guys. Well, hopefully we will see you all next week. And have a great rest of the week, everyone. We'll be sending out the presentation if you're on our email blast probably later today once we get the download and put it up for you guys so you can watch the rewind. And again, any questions, keep them coming. You know how to reach us, and we'll see you all later. Have a great week. Thank you.
Have a good week. Thanks, Dan. Great presentation.
Thank you, guys.
Nice job, Andy.
Thank you. See you guys. Bye.